And today we are going to graph standard form. So yesterday we looked at how to find the axis of symmetry. We learned how to find the vertex in standard form and the y-intercept. So today all we're doing is taking that information and putting it on a graph. So again, just like yesterday, we're going to start by finding that axis of symmetry. Remember, the equation is, let me write that down for you again in case you forgot. X equals the opposite of b divided by 2a. So for our equation, we have x equals opposite of b divided by 2 times a, the coefficient of our x squared, which in this case is 1. Negative 8 divided by 2 is negative 4. To find the vertex, we take that value, substitute it back into the equation for x. So we have y equals negative 4 squared plus 8 times negative 4 plus 8. Remember, negative 4 squared is negative 4 times negative 4, which is positive 16. 8 times negative 4 is negative 32 plus 8. So we have 16 minus 32 is negative 16, plus 8 is negative 8. So our vertex is negative 4, negative 8. Y-intercept, that's our quick one. We look at that constant for the function, meaning that one term that's not being multiplied by an x. So we get a y-intercept of 8 as an ordered pair, 0, 8. All right. Now we're going to take all of those, put them on the graph, and just like when we graphed factored form, we're going to be using that axis of symmetry. So we don't graph the axis of symmetry till we have our vertex plotted. So we're going to start with that. Negative 4, negative 8 is our vertex. We're going to plot our y-intercept, 0, 8. And then remember that axis of symmetry for the standard form, we don't have the zeros. So we really need to use this axis of symmetry to give us an idea of where this parabola is going. So flipping the y-intercept across the axis of symmetry gives us another point off to the left. So now we have 3 points, so we can graph our parabola. We've got here our y-intercept and our vertex. So those are the 3 points we're going to use to graph our parabola. Remember, your vertex is your turning point. Try and make sure that you don't have any flat bottoms at your vertex, a nice rounded curve. Let's just keep practicing that with some different equations. We're going to be seeing different coefficients. First, we're going to set up our axis of symmetry. Opposite of b divided by 2 times a, negative or negative 1. Negative 6 divided by negative 2 is 3. Getting our vertex, substituting that back in for x. Remember, don't lose that negative, that's your coefficient in front of the x squared. So we have 3 squared is 9 times negative 1 is negative 9. 6 times 3 is 18. Negative 9 plus 18 is 9, minus 1 is 8. So we get a vertex of 3, 8. 3 from that axis of symmetry, and then 8 from our substitution. Y-intercept, our nice easy one. The constant, the term that has no x value, is our y-intercept. All right, we're going to graph these and use our axis of symmetry. So we have a vertex at 3, 8. Our y-intercept is 0, negative 1. So in order to get some other direction, we're going to make this imaginary axis of symmetry again. Flip our y-intercept across the axis of symmetry. And now we can tell that our parabola is opening down. Remember, we knew before we graphed that our parabola was opening down because this lead coefficient is negative. All right, so think about, does this graph open up or down? We're going to decide that before we graph this time so that we know if our graph matches our equation. So looking at the lead, it's called the lead coefficient, the number that you multiply by x squared. If it's positive, it opens up. If it's negative, it opens down. So I'm going to say right here, so we don't forget, our graph opens down, and we're going to make sure that matches the points that we plot. All right, axis of symmetry, x equals the opposite of b, or positive 12, divided by 2 times a, that lead coefficient that we just looked at to decide our graph opens down, negative 3. 12 divided by negative 6 is negative 2. To find our vertex, we substitute that back into the equation. Negative 3 times negative 2 squared minus 12 times negative 2 minus 8. All right, order of operations, we've got to do those exponents again. Negative 2 squared, or negative 2 times negative 2 is positive 4. Negative 12 times negative 2 is positive 24. Negative 3 times 4 is negative 12. And adding and subtracting left to right, negative 12 plus 24 is 12, minus 8 is 4. So our vertex, we started with an x-coordinate of negative 2, solved to get 4 for y. And finally, our short one, our y-intercept, that constant is negative 8, so we have a y-intercept of 0, negative 8. Putting all of these points on our graph, which we know will open down, so we're going to be thinking about that as we graph, making sure that our graph matches what we know about the equation. Y-intercept 0, negative 8. Plotting our axis of symmetry so we can flip that y-intercept across it. And it does look to me like my parabola will open down. We're going to get a real skinny parabola here. Last one, of course, we couldn't have a lesson without a fraction, so let's take a look at the axis of symmetry for this one. Before we do that, actually, let's decide if it opens up or down. So we're looking at our lead coefficient. It is positive, so it should open up, and we'll make sure that matches our graph. All right, x equals the opposite of b, or positive 2, divided by 2 times a, that 1/2 we were just looking at. Half of 2 is 1, so our axis of symmetry is x equals 2. To find that vertex, we substitute that back in for x. Exponents before multiplication, 2 squared gives us 4. Negative 2 times 2 is negative 4. Half of 4 is 2. 2 minus 4 is negative 2, plus 9 is 7. So we have a vertex of 2, that x-coordinate we got for our axis of symmetry, y value of 7. And everybody's favorite, because it's so quick, substituting 0 for x, we would get 9 for y. Plotting all of our points, thinking about the fact that our graph should open up because we looked at our equation. 2, 7 is our vertex. 0, 9 is our y-intercept. Plotting our axis of symmetry and flipping our y-intercept across it. We do have a parabola that barely fits on our graph, but does open up, just like we thought it should. And your U-try problem. Sorry, I'm noticing a graph is missing. I will get that on your notes for the notability.